Hey everybody, welcome to our webinar today, Home Air Filtration. Uh, this is Joe Wachunas from Electrify Now here with you as always. I'm joined also by Wesley Allen, who's been leading up our Clean Air Week. These are all the webinars that we're doing throughout the week about how to electrify your home and clean your air, both indoors and out. And then we have Brian Stewart, founder of Electrify Now, who will be our panelist today, which is pretty exciting. So we'll get into details on that in a second. But Wesley, talk to us a little bit about Clean Air Week 2025. What are we hoping to do this week?
Yeah, thanks, Joe. So Clean Air Week is a virtual online week with the exception of one in-person event put on by Electrify Now and partner organizations to really highlight the health risks of using natural gas, particularly indoors. And so during this week, we have a slew of different webinars to provide practical resources to improve indoor air quality, to bring together different advocates of electrification, and to really support the crucial work that different organizations are doing to clean our indoor air. Um, Next slide, please, Joe. So during this week, we've already had one webinar yesterday on the dangers of burning natural gas. Today, we're so lucky to have Brian here to talk about home air filtration. And then tomorrow, Wednesday, we're going to talk about home air quality monitors. Thursday, we have a webinar on kind of beginning electrification. So how to come up with a plan, where to start in terms of electrifying your home. Uh, Friday, we're really lucky to have about 5 experts from around the country to talk about policy updates in the decarbonization space. So what are states doing or local jurisdictions doing to really create healthy air standards and cleaner indoor air? And then lastly, if you are in Portland, Oregon, we have a local event called Electrify Portland. It's a home electrification fair, so we hope you'll join us for that.
Yeah, we'll put links in the chat to those. And our YouTube video from yesterday's webinar is coming soon.
We also wanted to mention that on our website, and the URL is there, and I can put that in the chat as well. We have a host of shareable graphics and resources. So there are some examples here. We have fact sheets, little fact cards on the different pollutants in natural gas and some of their health risks. Call it or getting to know what's in your natural gas series. And we have some graphics, so feel free to use them. They're for public use and get the word out on some of these health concerns about natural gas. We also have a few fact sheets from Electrify Now, including one on home air filtration. So I'll put that in the chat in just a couple minutes. And this was a fun one. So during Clean Air Week, we are hosting a natural gas quit line. So you can call 1-877-QUIT-GAS if you're ready to transition off natural gas. And we have experts, so leave a voicemail, and we have experts that will respond to help you problem solve or give you a sense of where to start in your electrification journey. So yep, call 1-877-QUIT-GAS.
Great. Well, thanks. All right. Well, so today we're going to be diving into home air filtration. We're talking about clean air this week. So, how do we filter our air? There's a couple of reasons, why we might want to filter our air. Brian will be diving into depth. What are these common indoor and outdoor air pollutants, and where do they come from? How are they generated? We're going to talk about what are some different solutions, from furnace filters to smaller air filters that you can have in a room. Brian's going to give us a little practical guidance for both homeowners and renters on how to improve their indoor air. And we're going to look into HEPA filtration, MERV, and CADR ratings as well. So you're going to be an expert in all the home filtration lingo when we are done. And today's guest, you know him from moderating many of our webinars. It's Brian Stewart. He's the co-founder of Electrify Now. He co-founded it a couple years ago, what, 5, 6 years ago, to help energy consumers and homeowners learn about the benefits of electrification. He's got over 40 years of experience in product design, engineering, manufacturing, and sustainability, and held many leadership roles at Nike, including Vice President of Sustainable Innovation. A man who needs no introduction. Brian, thanks so much for being here and sharing your expertise on home air filtration.
All right. Well, thanks, Wesley and Joe. That's awesome. I'm really excited about this. I love the quick gas hotline, by the way. That's genius. All right. So today we're going to be talking about home air filtration. And the good news is that this is really a fun topic because there's such good solutions in this space, but it's really helpful to understand, kind of what you're looking for. So that's what we're going to get into. I always like to start with just reminding people that, going electric in our homes is so good for so many reasons. Today we're really talking about indoor air, but there's all sorts of benefits from going electric with our homes, including lower energy bills, and of course, it's the lowest, it's the most effective thing you can do to lower your personal carbon emissions. But today we're really talking about indoor air quality. And so the question is, why is it that air filtration is so important? Well, the American Lung Association does a regular kind of state of the air report, and they reported recently that nearly half the US population lives in places with unhealthy levels of air pollution. And the causes for this are not too surprising. I mean, more and more it's about wildfires, especially here on the West Coast. But if you live near or in an urban area, basically the air pollution that comes from cars, buildings, and any kind of industry that's in the area, unless you've got a stiff wind, you're going to get urban air pollution 24/7. And so that's important. Here on the West Coast, we frequently get ocean breezes that clears it out, but we see it here in Portland. Anytime there's no air, the air quality goes really bad. And then there's indoor sources of air pollution. The main one is cooking, but any gas appliance can potentially also produce other sources of indoor air pollution. And we're going to talk about all that today. The other reason why this is so important, because we're talking about air filtration, is that we spend 90% of our time indoors. So that's good in some ways, because it's relatively easy to control indoor air pollution. It's harder to control outdoor air pollution. So if you spent 90% of your time outdoors, there would be fewer solutions. But here we're talking about indoor air quality. All right. So I think a good place to start is just understanding the air quality index. This is a tool that the EPA created. I think it dates back to the 70s. And the idea was to measure 5 important, what are called criteria pollutants: ozone, particulates, which we'll talk a lot about, carbon monoxide, sulfur dioxide, and nitrogen dioxide, which is a really nasty one, and that one's related to gas stoves as well. So they have this kind of index that's basically 0 to 300 and above. And essentially 0 to 50 means the air quality risks are really low. 50 to 100, it's like moderate. Over 100, basically what that means is that some at-risk populations should really be careful. I think if it's much over 50, you ought to be careful about exercising outside when you're, like you're just really exposing your lungs to particulates and other nasty things. And then of course, when it's in this red and purple zone, you really just do not want to be outside at all unless you're wearing a mask. And inside, you really need to be careful and use all the tools that we're going to be talking about. Okay, so there's really good data now about air quality. I'm really a fan of Purple Air. We got a Purple Air monitor about 10 years ago, and at the time, you wouldn't have seen near this many data sites, but outdoor air monitors have just exploded in terms of proliferation. And so now, even in relatively unpopulated areas, you're going to be able to find a monitor that's not far from you to give you an idea about what's going on in your area. Because one of the things you find about air pollution, outdoor air pollution, is it can change massively, 10 miles away can be way different than where you are. So having a monitor that's nearby is really important. So these sites like Purple Air, Air Now, there's others. We'll talk more about that in our air monitoring webinar tomorrow. Give really good information real time. But when you look at a map like this, the United States, basically this is a relatively good good day, so to speak. A lot of green, but essentially what you're going to see if you looked at this regularly is on any given day, there's bad air somewhere in the United States. And when we have wildfires, that's you can get huge areas of the country that are red or purple. So we have good information about air quality and air quality index. Another really important thing to understand that's related to the air quality index is air pollution particle size, because all air pollution is not created equal in terms of the effects it has on our human physiology. But basically what you see is there's things like pollen, which some people are very allergic to and have bad reactions to, are relatively large molecules, roughly the size of a human hair, the diameter of a human hair, or a little bit smaller. And then mold is smaller. Dust comes in all sorts of sizes, but you can see it in some cases it's so small you can't. And all these things get down to the very small sizes like smoke and viruses. But essentially, the important thing to understand about this is, the doctors basically agree that 10 microns and above, these particles that are bigger than 10 microns are going to, they're not necessarily great. They can provide or elicit some temporary irritation, like, runny nose, allergic reactions, etc., itchy eyes, etc. But it's the stuff that's smaller than 10 microns, and especially the things that are smaller than 2.5 microns. That's often referred to as PM 2.5. You hear that a lot. These are the small particles that can get deep into your lungs and even into your bloodstream, and associated with high risk of all sorts of really unpleasant and life-threatening diseases: asthma, bronchitis, lung disease, heart disease, stroke, diabetes, even dementia is seen to be correlated with PM 2.5 exposure. And it's important to understand that this exposure we're talking about is cumulative. So the more often you get this exposure, even if it's relatively modest, it adds up, because your body is basically unable to get rid of these small particles, which is why air filtration is so important. Okay, so how is it possible to avoid these exposure to air pollution when we're inside? And of course, those sources are going to be, like we said, urban air pollution, wildfire, car exhaust, but even natural gas combustion and cooking pollution inside, which we'll talk about more later. But for outdoor air pollution, the first thing to do is close windows and doors. Most homes, though, are not going to be completely sealed. In fact, it's almost, in some cases, you don't even want a home that's completely sealed unless you've got really good air return systems. But close those windows and doors. And then a really good thing to do is to turn your furnace or heat pump filter to on, not auto. And most of the time your fan for your heat pump or furnace is going to be in the auto position. So if you're worried about outdoor air pollution, a really good thing to do is set your furnace or heat pump fan to on. So you can see in this thermostat here, it's in the auto position, but if you click the button, you can turn this to on. And that means that the fan is running all the time, even if there's no heating or cooling happening, which means that you're getting lots of air through your filter, which is going to have a surprisingly effective result on keeping your indoor air quality good. But that often is not enough. So that's why these air purifiers, these small portable devices that are really not that expensive, we're going to be talking more about those, are so good, particularly for areas that you spend a lot of time. Like, I'm a high proponent of having one in bedrooms and in living areas, for example, or if you work at home, have one near where you work. Okay, so it's important to understand these filter ratings, because this can be confusing. If you're talking about filters for furnaces or heat pumps, the rating that's important is called a MERV rating. And you can see that they give information for the particle removal efficiency for these different size microns, really small, 0.3 to 1 microns, 1 to 3 microns, and then the larger ones, 3 to 10 microns. So you can see that what this is saying is a MERV rating of 10, for example, doesn't filter out any of these really small particles, but it will filter out about 50% of the medium-sized ones and 80% or more of the larger ones. Now you can get more higher MERV ratings like 12 to 14 that start to filter out these really teeny ones. And then they go all the way up to 16. It's really hard to find a MERV 16 filter, and they're expensive, but these things will reduce 95+% of all these particle sizes, which is pretty good. And then the next highest rating is called HEPA. And you really are not going to be able to find typically a furnace or air heat pump filter that goes in your air handler that's HEPA rated. So mostly you're going to be finding one of these high MERV rating filters for that situation, but HEPA is really common in the air purifier space, which we'll be talking about. It's also important to realize, though, that the more these filters can filter out, the less air that goes through the filter typically, because it makes sense, you know, they're finer mesh. So it's important to older furnaces, for example, sometimes struggle with really high MERV rating furnaces. It's something you might just want to think about or look into. New furnaces, you should be able to put in a 14, no problem. But older ones, you might have to back off a little bit or risk not enough airflow. And then, of course, you know, the more effective they are, the more expensive they are typically. But as we'll see, they're not really outrageously expensive. So for your heat pump or furnace filters, they're going to, obviously they come in different sizes and thickness. You know, the size has to do with the square, you know, the square inches, you know, width and height of the filter, but then the thickness is something that your system is going to be set up to accept. One of these common ones are 1 inch, 2 inch, or 4 inch filters. It's better to have a 4 inch filter. It's a lot better to have a 4 inch filter, but you can't put a 4 inch filter in an opening that's only 1 inch wide. So this isn't, you know, you have to know what your system has. But if you're thinking about a new system, make sure that you're putting in a 4 inch filter, because that's going to have way more surface area and do a better job of filtering your air. Just as a reference point, you know, a 1 inch MERV 10 to 13 filter, which is about as high a MERV rating as you're going to be able to get for a 1 inch filter, they cost $15 to $20, $25 maybe. For the 4 inch versions, where you can find 11 to even as high as 15 MERV, now you're talking more like 25 to 50. So they're more expensive, but, you know, well worth the money. 3M, unfortunately, has their own confusing ratings. They call it MPR, but you can usually find a correlation to MERV. MERV is the gold standard, so I would really use that as a reference point. Consumer Reports has good information about buyer's guides, but in general, you know, I think if you just really look at the MERV rating and price, you know, find the highest MERV rating for the price, you're going to do pretty well. And then it's important to remember that you need to replace these things pretty frequently. You know, it depends again on how much dust and stuff your home is subjected to, but at least every 6 months, I would say. I mean, worst case scenario, once a year, but it's good to put these on a timer or something to remind yourself to do those replacements. Okay, let's talk about air purifiers, because that's kind of maybe the meat and potatoes of this presentation today. They're sold by room size typically. So basically that means, you know, that's a physical size thing. For a small room, you can get away with a smaller physical unit, but it really has to do with how much air is moving through the filter. And so obviously, if you're trying to keep the air clean in a big room, you need more airflow. So they're typically sold in these sizes of small, medium, large, or they're referred to that way. The ratings are, and like Consumer Reports, for example, organizes it this way: 150 square feet or less, 150, 350, 350, 650, etc. So the best models, and pretty much all of them now, have HEPA fine particle filters, which is great because, like I said, this is the gold standard for air filtration. It used to be hard to find HEPA filters. They're really common now, which is great. Most of them also have activated carbon filters. Those are primarily there to reduce odors. They can reduce some volatile organic compounds. We'll talk more about this. But really, I think when you're looking at these typical filters they're really set up for particles and odors. And we'll talk more about how to get rid of volatile organic compounds, which are nasty gases. That's really a different kettle of fish when it comes to air filtration. And these models that we're showing, and most of you are going to be able to buy at an affordable price, don't really do a great job of VOCs, but they're really good for particulates and odors. They're going to cost, a small one a good one for a small room could be as low as $70. You might spend as much as $500 for a big room, although I think you can get a really good one for about $250. We'll talk about that. Consumer Reports has great ratings. They also rate the top brands. Blue Air is one that I'm really familiar with. We've got a bunch of them in our homes, and I'm a big fan of those, but there's other ones from Honeywell and other suppliers that are also rated really highly. Okay, the other thing that is important to understand as a rating for home air purifiers is what's called clean air delivery rate. And this is a performance-specific rating for 3 particulates: pollen, dust, and smoke. And generally speaking, the reason why they do it this way is pollen is big, dust is medium, smoke is small. I should have put it in that order. It's really pollen, dust, and smoke. So that relates back to the MERV rating we were talking about, where it's the particulate size. Smoke is really tiny, dust is medium, and pollen is larger. So you'll get 3 ratings for each of those. And it has to do with a combination of how well the device is filtering out those particles and how much air is moving through the filter. So it's combo factor that's basically gives you a really good idea about how effective this filter is for cleaning the air in your room. So for a big room, you need a high CADR. And the other advantage to a high CADR, clean air delivery rate, is that if you run it on low, you're still getting really good air filtration with less noise. So that's important when it comes to like rooms that you sleep in, for example. Okay, we'll talk more about that in a minute. Okay, so what about air pollution from cooking? So far, we've really mostly been talking about particulate size. Well, we had that great webinar yesterday that, it's shocking. We just get more and more information about these really nasty byproducts of combustion: nitrogen dioxide, benzene, formaldehyde, and leaking methane. All these things are really associated with nasty health outcomes. The American Medical Association says the use of a gas stove increases household air pollution and the risk of childhood asthma and asthma severity. This recent study from Stanford shows that a single gas burner can create concentrations of cancer-causing benzene that's similar to secondhand smoke, and lifetime cancer risks double for children that live in homes with frequent gas stove usage. So basically, gas stoves are incredibly dangerous. So the question is, will an air purifier capture these VOCs that we're talking about, nitrous dioxide, benzene, formaldehyde? Will these air purifiers work? The short answer is no, unless you buy a very specialty filter, because most of the air filters that we're talking about, the air purifiers, are really great at capturing particulates, but those activated carbon filters that they have are really more designed for odors. And the reason for this is that an air purifier needs pounds of carbon in order to absorb VOCs effectively, because this is a different mechanism. You're not running, with a filter for particulates, you're running air through this mesh and you're trapping these fine particulates. For VOCs, activated carbon absorbs the gases over time, but you need a lot of it and a lot of surface area in order to do that filtration. The other thing that's tricky about this space is, unlike those ratings that we've talked about, MERV, HEPA, et cetera, and all the testing that goes with it, there's very few clear standards and testing for this VOC kind of absorption thing, at least not in the, for we lay people. You know, if you're in a lab or something, I'm sure that data is available, but for these devices that we use in our homes, it's really not common. There are products like, here's an example, the IQ Air GC Multigas. This costs $1,600. And it takes 4 of these carbon filters that cost over $400 for a set that you need to replace every few months. So you're talking about multiple thousands of dollars for a device to remove the VOCs from your gas stove, for example. It's cheaper just to buy an induction stove. That's the truth. And you'd be better off anyway, because you'd have a better cooking experience. It's easier to clean, blah, blah, blah. It's just a better product. So I just don't think this whole concept of looking to air purification for VOCs, it's not a thing, if you ask me. It's like the best thing to do is replace the devices that cause the creation of volatile organic compounds in our homes. And that it means stoves, even water heaters, furnaces, et cetera. Get rid of those things. It's going to be cheaper than filtering the air. All right. But if you can't do either one of those things, you can't buy the filter, you can't replace your stove right now, there are some things you can do. Avoid using gas. There's a lot of really great electric countertop appliances, like small induction burners, electric ovens, you know, air fryers, et cetera, that you can use instead of your gas range or gas stove. Another important one, and this is true even for induction or electric ranges, you want to avoid heating over 400 degrees. I mean, it's kind of crazy to me that most recipes really frequently tell you to cook at 425 degrees. You don't need to do that. You know, 350 degrees is plenty hot for almost any cooking thing. It means it's going to take slightly longer, but generally speaking, that means less drying out, et cetera. We, as a rule in our house, really try to avoid cooking at 400 degrees because really nasty things happen over 400 degrees. You get all sorts of chemical reactions that happen that create particulates and other nasty byproducts that you just don't want. The other thing to do is to avoid cooking with oils that have low smoke point, like olive oil, for example. I love it. It's great in cold recipes, but don't burn it because it burns at low temperatures and then it's creating all these nasty particulates that you can avoid if you use other oils like avocado or sunflower that have higher smoke points. And then, of course, use your ventilation whenever you can, open windows. But it's important to realize that hoods are good, but they're not really, really, really effective. We had some really good data on that yesterday. And also some hoods, all they do is blow the air back into your house. So, you know, yes, use it, but just know that it's not going to be a cure-all for these things that come from our stoves, everything from the benzene, et cetera, to the particulates and the nitrous oxides are not eliminated by a hood. This data from Stanford that shows 2 cases using an oven with the hood off. Of course, you get this huge spike in nitrous dioxide in the kitchen. But even with the hood on, over time, you've got levels that are more than what the EPA says is safe. So the hood is good, but it's not, it doesn't cure everything. Okay, so back to air filters, air purifiers. If you're thinking about buying one, what should you look for? Of course, make sure it's got a HEPA filter. Most of them nowadays have at least the option of including filters that have carbon filters, which is, you know, why not? It's going to reduce some odors, but in general, it's HEPA filtration that is the key thing, if you ask me. Okay, you're going to see some that advertise ozone filters and UV-based filters. Avoid these at all costs. Ozone filters are actually potentially worse than no filtration because ozone is a pollutant. Remember the EPA air quality index includes ozone. Why would you want to create ozone in your home when that's considered a criteria pollutant? And then UV-based filters just basically are shown to be very ineffective. So I would just say if just don't go there. You want to find a a filter, a air purifier that's got multiple fan settings, and I really like the ones that have night mode, because if you're sleeping, you just want to have continuous but very low levels of air fan speed, so that'll be quieter. It's unfortunately harder to find these DBA ratings, but some of the better ones like Blue Air, again, I'm a fan of Blue Air. They will tell you what the sound ratings are. And if you've got one that's in this 20 to 25, some of them are even quieter on the low settings, that's great, because you're barely going to be able to hear that. And it's great for rooms that you sleep in. And then, of course, these CADR ratings, sometimes you have to dig for those. If you have a filter that you're attracted to and you can't find the specs, Google CADR ratings for that filter, and oftentimes our Google brain will find it for you. But you want, for a small room, you want at least 100 CADR for all those 3 ratings. And as the room gets larger, you need higher ones. For a large room, you need 300 or more is a good rating for a CADR. And then, of course, you should check just to see how easy it is to replace filters, because that's something you want to be able to do without it being a hassle. And then, filters costs also something you might want to consider, because those are something that are going to cost you some money every 3 to 6 months. Consumer Reports has some great ratings, again, organized by room size. And then, here's just some examples of some top rated models from them. I'm not going to go through this as all, but for a large room, again, I've mentioned, I'm a big fan of Blue Air models. One of the reasons why I like them is they have these removable cloth skirts kind of that go on the outside that trap all the big stuff, like big dust, dog hair, etc. is going to get stuck on this cloth coating that's on the outside that you can throw in the washing machine. And that keeps all that stuff out of your HEPA filter and doesn't clog your HEPA filter, which means your HEPA filters last long. So for $250 for a big room, you get this excellent CADR ratings. We mentioned they need to be over 300, and very low on low ratings. They get a high Consumer Reports score. Consumer Reports also has, this is one of their top models for medium rooms. Here's another one on their top models for small rooms. I guess what I would point out from this, though, is look at this. The prices are virtually the same. There's no sound rating for these other two, but they're subjective reports that these are noisy. Their CADR ratings are way lower. So in my opinion, you should just buy this one for all 3 rooms and run it on low. In your bedroom, you're going to get really good air filtration. So I don't know, that's one of the things that about these ratings I think are imperfect, because the price is so important. This is a really good, what this is showing is this is a really good model for almost any situation. Okay, but all that information is on Consumer Reports. There's other ones like Wirecutter, etc. All right, and then bottom line, how are you going to use it? You got this thing. Make sure you put them in the rooms that you live in most, like bedrooms for sure, because you're going to spend at least 8 hours a day in that room. Kitchens is a good place. Living and working areas, another good place. Run them when you cook. Run them when you know the air quality is bad. Run them on low or night mode when you sleep. Replace the air filters like we mentioned. Okay, and then finally, we're not going to get into this a lot. We've got a whole webinar on this tomorrow, but it's really helpful if you've got air filters to know when to use them. So there's great information on websites from places like Purple Air, Air Now, IQ Air, all have really good outdoor air quality information. You can get phone apps from all those places, so you have it right at your fingertips. And then, of course, there's indoor air quality monitors, and ones that show indoor and outdoor air quality. We'll talk about all this tomorrow, but basically, once you get into this, it's kind of a no-brainer to get an air quality monitor, because now you've got both of the things you really need: information about when to filter and good solutions when the air gets bad and you need to turn them on. So that's it. Thank you, and yeah, let's have some Q&A.
Great. Thanks so much, Brian. That was an awesome tour of how to filter your indoor air and what are the different options. Maybe we could start with the air filters and replacement, as we're getting a couple questions and comments on that. One person is saying, are there any companies that might recycle old filters? They say continual disposal of filters is an unfortunate outcome of filter use. And then just to add on to that, Rachel's saying, what filters are available that you can wash? What can you vacuum clean and use again? So maybe just walk us through the like how often we really need to change filters. Is there any option for recycling? And tell us more about that washing.
Yeah, no, those are good questions. Well, let me just start out by saying that, okay, it's true that you need to replace these things relatively, regularly, because they're going to get clogged. Having said, and when they get clogged, what that means is that they stop kind of doing a good job of filtering. But having said that, I think it's important to realize that, selling you air filters is a way that these companies make money. It's kind of like, there's a lot of people talk about this. It's like, razor blades. If you're a guy, you understand this. The little shaver thing is really cheap, and then you spend a fortune on the blades. Okay, so it's a little bit like that. So I just want to point out that you should be aware that you're going to get a lot of information telling you need a subscription, and they're going to send you filters all the time, or replace them every 3 months or whatever. I would take that with a grain of salt. And if you have an air quality monitor, you're going to know when your filter's not working. But I think 6 months is I don't see very many situations where you're going to need to replace them more than every 6 months, maybe even once a year, because you don't need to run these all the time in most cases. Like if you live in a city with really bad air quality, maybe you're running it all the time. Maybe you need to filters regularly. But for most people, 6 months or a year, every once in a while, it's going to be enough. And if you've got an air quality monitor, that you're just going to know if it's not working. Okay, so that's the first part. You didn't even ask that question, but I wanted to start with that. Okay, in terms of washing them, not really a thing. Like I mentioned, you can wash sometimes these external screens that keep all the big particles out. Yes, but the filter itself, you might have some luck by maybe you can vacuum it and get some of that stuff out. But keep in mind, if you vacuum it, you don't want to do that inside, because you're just going to be pushing most likely all that nasty stuff that the filter collected is going to just get pushed back into your room by the vacuum. So I guess do that outside, but I don't think that's going to be very effective. It might give you a few weeks of life out of your thing, but I don't know. I don't think that's really a thing. And then in terms of recycling them, that's a good question. I'm not aware of that being an option, but for the most part, these things are paper. You could potentially, they might have some plastic associated with it. You might be able to pull it apart and, recycle the paper parts of it. But I'm not aware of a recycling program for filters, but I don't know if someone else on the call is, you please put that in the chat.
Thanks, Brian. We also have a good question about where to put an air purifier. So one of our participants says that they have one in their home office and each bedroom. Where else might one consider putting a home air purifier?
Yeah, I think those places are good. I mean, the way I think of it is wherever you're spending a lot of time, you should have one. And then the other thing is, maybe you don't spend as much time in your kitchen, but if you're creating indoor air pollution in your kitchen, you gotta have one there, because eventually those particulates and other nasty things are going to find their way into the rest of your home. So you might as well like filter it out where it's coming from. So I'd say kitchen's a good place. Living rooms, work areas, and bedrooms. Those are the main places. You don't need one in your bathroom probably. But yeah, the places where you spend most of your time. Kids' rooms. I mean, Joe, I know you've got a good story on this, but yeah, if these things were available and we had children, I would have one running 24/7 in my kids' rooms, because kids, their kids are more susceptible to air pollution than anyone else, other than maybe old people who have respiratory conditions. Kids, because their lungs are developing, you just have this real kind of like situation where they're most susceptible to potentially life altering, impacts from air pollution when they're young. So I would absolutely put one in my kid's bedroom and run it all the time, regardless of what the outside air quality was. Probably. Joe,
Yeah.
I know you've got a good story
Oh,
there.
just a plus one on that. Yeah, our youngest daughter has asthma and would frequently cough at night, even with inhalers. And we just didn't think to put in an air filter until about a year ago. And then since then, we've noticed every night a lot less coughing because it's filtering the air. She's allergic to dust mites, and it's just helped immensely, from our experience. Yeah. Well, hey, Brian, another question for you, because kind of on the nuts and bolts, you talked about the heat pump, or the central heat pump or furnace filter, and how that can help be a good option for cleaning up the air. What about folks like me who have ductless heat pumps?
Mm.
Are the filters there useful in any regard? What are your thoughts on that?
That's a great question. The short answer is no. The filter that's in a ductless heat pump is there to protect the heat pump, not to protect you. I mean, so basically what it's doing is it's trapping big stuff like, big, really big, nasty dust particles, human hairs, etc., things that could potentially interfere with the operation of the heat pump. So it's not really there to filter the air for you. So essentially, if you have a ductless heat pump, and I'm a huge fan of those, we have one in the room I'm in, they're amazing, but they do not filter your air. You need an air purifier in that situation. And again, fortunately, the thing is that, that's not a ding, for like $250, you can get a really good air filter that's going to take care of the air in that room that is being served by the ductless system really effectively. So yeah.
Great. Brian, we have a question from Rob. It's a great question. I'm not sure if we have the answer to this one, but he was wondering if we have any experience on bulk orders for air filters, for replacement air filters. He's thinking about like particularly grant funding or something like that for overburdened neighborhoods
Mm.
that might not have the resources to change air filters when needed for home purification.
Yeah, that's a great question. I'm not aware of that, but I think that is the type of thing that we should be doing. And, like here in Portland, for example, there are reasonably good programs that have popped up recently to offer portable heat pumps primarily to provide to income qualified renters and homeowners who don't have air conditioning in their home, because we're realizing that heat is a really debilitating problem, and a lot of people on the lower income levels don't have air conditioning. Well, it's 100% also true that those same people probably are suffering from bad air quality. So I think we should have these programs. I know here also in Portland, there's a PSEF program, which would be it's a Portland Clean Energy Fund. It's grant money essentially that's available for these types of things. I think that would be an excellent program to offer, but I'm not aware of one. But if anyone else out there is, please put that in the chat.
Great. Okay. I'm going to try to bundle two questions together. The first part is somebody's asking about how furnaces would emit these VOCs into the air. So we know that stoves, do a lot, but how about furnaces? And then just kind of on that technology, the second part is portable ACs or room ACs purify the air with the right filter?
Okay. All right, let's start with those portable ones. Again, the short answer is no, they're not providing any air filtration. The filters that are in there are mostly there to protect the device. I think some of the more high-end ones, like the Gradient cold climate portable heat pump, which is $3,000 device. That one, I believe, does come with some pretty decent air filtration that is for room occupants, not for the device, but most of them, no. And then the other part of that question was around furnaces. Do furnaces create these VOCs that we're talking about? Yes, they do create them. They're vented to the outside, and I think that typically the ventilation systems for furnaces, and the same is true for water heaters, are generally speaking pretty good. So how that works is that you've got the furnace in your basement, for example, all the combustion is right there. There's a flue, and the reason that there's a flue that goes to the outside, so you'll see on top of your house, there's a little pipe that's sticking up, or sometimes it comes out the side of your house, is ventilating those gases. That's like the tailpipe on your car. It's a 100% equivalent, except that you can't see anything coming out of it, but it's just dumping all that nasty stuff out into your neighborhood. It does a pretty good job of keeping it out of your house. There are a few exceptions. And some of the studies, Eric LaBelle, who was on the webinar yesterday, has done some research that shows that there are situations where, particularly with water heaters, old water heaters, it's not uncommon for the ventilation on those to be overcome by something like a fan or a ventilation system in your home. So say you've got a kitchen, a stove hood on your stove, and that's pushing air outside. It's got to suck air from somewhere else. It's sucking air from inside the home, and it's potentially sucking some of those VOCs into your home from your water heater. If your water heater is kind of quasi effective at ventilating the fumes from the combustion so I think that's going to be infrequent and uncommon, but I don't know, it's a thing. It's not well studied. There aren't very good ways of monitoring that, so it could very well be happening in that situation where if you've got a really big, like we've got a giant almost like commercial quality hood on our stove, and it's, if you had a big hood like that, it might be sucking bad things from a furnace into your home. It's possible. Or the other culprit might be a gas fireplace. So yeah, it's something to be concerned about. I think, like I mentioned, the only way to be sure that you're not getting VOCs from combustion in your home is to eliminate things that have combustion in your home. And and there's all sorts of good reasons to do it anyway. So yeah.
Yeah, that's a great point. Malfunctioning venting can be an issue, but also malfunctioning like appliance itself. We wrote an article recently in Clean Technica on carbon monoxide and kind of the failure of someone's furnace and the health problems that caused in their life. It took a really long time for them to figure out what was going on and causing dizziness and headaches and nausea. And so the device, in addition to ventilation, can also fail and release those VOCs into the indoor space.
Well,
Yeah.
I'm glad you brought up carbon monoxide, because we haven't talked about that a lot. That's a really dangerous air pollutant. There is no filtration available for that. Really, the only solution for carbon monoxide poisoning is dilution. You have to like dilute the carbon monoxide to a point where it's not dangerous. So the detection of carbon monoxide is really important. That's why, and we'll talk more about that tomorrow in our air monitoring conversation, but that's why, carbon monoxide monitors are so important, because, there's no way to filter that. You just have to know that it's happening and shut down the device that's creating it. And stoves are a potential source of that. Fireplaces, furnaces, water heaters are a potential source of that.
Go for it.
The gas burning ones, by the way, not the electric ones. The electric ones won't,
right.
no carbon monoxide. If you have an all electric home, you essentially do not need carbon
I
monoxide
know.
monitors in your home.
I love that about my all electric home. Like, I don't need this carbon monoxide.
Yeah,
There you
you know
go.
those things that the battery goes out and they start beeping at you and you can't find which one it is because you don't need those.
Yes. Amazing.
The carbon monoxide versions of it.
Yeah.
Smoke, yes,
Okay.
but carbon
Fire
monoxide, no.
alarm. Yeah. Maybe a quick question, again on these like VOCs, volatile organic compounds. Someone's asking, can an induction range and stove create VOCs when baking? Sounds like there's value in running both an air purifier, like you were saying, Brian, plus a hood vent while baking or cooking. That is something that you were talking about a little bit. Running the hood vent when you're baking with the oven. I never think to do that.
Yeah,
Talk to us about that in like an induction range with an electric.
yeah. Well, from the research I've been able to find, the answer to that is no. Cooking on high heat does not create VOCs. From what I can see, the only thing that creates VOCs, like benzene, nitrous oxide, formaldehyde, is gas combustion, propane or natural gas combustion. Having said that, like there's other nasty things that come along when you cook at high heat, mostly in the particulate and smoke area. Soot, other nasty things that happen at really high temperatures. But from the research I've done, I'm not a health expert. From the research I've done, it shows that cooking with high heat on an induction stove or an electric stove will not create VOCs.
Yeah, we did see that yesterday in yesterday's webinar as well. And what about that running the fan, while you're baking? Is that
Oh yeah, great question. Absolutely. I think with my wife, she's an excellent cook. She cooks a lot. I cook less than her, but I always have to remind her to do that with the stove, with the oven, because it isn't sort of like instinctive. But yes, when you're running the oven, absolutely. If you've got an air monitor in your kitchen, and we do, you'll see it really quickly. Even like sometimes toasting bread, can create really high levels of particulates in your home. So if your air monitor is close to your toaster, you're going to see things like that. It's really illuminating, which is one of the reasons why I think air monitors are so good for us, because it teaches us what's creating the stuff that's bad for us that we can't see. But yes, ovens, absolutely.
Yeah, I have an air purifier. I think it's the Conway or Conway, something like that. And something I've noticed, it has a little LED dial, and it's blue when the air feels clean to it, and it turns this bright red. And I've even noticed with things like
That's nice.
making the bed in the bedroom, and kicking up all that dust, or like you said, Brian, toasting will set off that little sensor, and it's just a little visual reminder of how sensitive our indoor air quality is to these things we do on a daily basis.
Maybe just, I love that story. The other thing it makes me think of is, back to this exposure to fine particulates in particular is a cumulative problem. So to me, this is the reason that it's useful to kind of geek out on this stuff, because it's easy to sort of say, well, yeah, the air's not great in my kitchen, but it's, open the window, it goes away after a while. It's not that big a deal. That's probably true. But on the other hand, years and years and years of breathing even air that's in the yellow range just means that you've got your lungs are a huge HEPA filter. You can't replace your HEPA filter that's in your body. It's not like an air filter, you get a new filter. That's great. You don't have that opportunity. So these fine particulates, the reason why they're so nasty is that your body does not get rid of them effectively. So they're going to be with you for life. So that's why I feel like every opportunity we have to reduce our exposure to fine particulates, take it. Because, when there's other places where you don't have the opportunity to eliminate that exposure, like, we have to go outside on days that, where the air quality is great. Most of us aren't going to be wearing a really good, like the kind of mask that eliminates PM 2.5 is like one of those big ones with the things on it. You know, you look like an alien. It's not a little COVID mask. It's a really big mask. So people aren't going to do that. So you're going to get exposed to this stuff over your lifetime. So why not reduce your exposure when you can, which is in your home?
Yep, that's great. Hey, question about filter, just maybe putting a fine point on the filter replacement. Somebody's asking if blue air filters in particular require filter replacement and how long do they last? I think for sure, pretty much all air filters will require filter replacement.
Yep. Yes, all of them will. Well, the other thing that I found is that, you know, some brands offer different types of filters. You know, they'll advertise them as an allergen filter or a special carbon filter, you know, odor filter. Personally, I feel like it's the HEPA filter that's the most important. I mean, the odor filter, I don't know. I mean, yeah, maybe if you got real odor problems in your home, that's important. But my point is that when you get to the replacement filter stage, you're going to oftentimes have the choice of the HEPA filter on its own, HEPA filter plus carbon, you know, fancy allergen ones. I don't know what that even is, because allergens, those are the biggest ones. That's the easiest stuff to filter out. I don't get why you would do that. That should be cheaper. But I would say just go for the HEPA one by itself. I'm a little skeptical about the carbon, to be honest. And it adds cost. So, you know, I don't know. If you're trying to save money, just stick with the HEPA filter. And then, as I said earlier, you know, all these filters are going to need replacement over time. But, you know, I think I'm a little bit, some of them will tell you they'll have a light that shows when you should replace it. I'm a little skeptical about that personally, because I think that's telling you when they would like you to buy another $35 thing more than whether the thing is really working. So, but, you know, there you go. I'm a little skeptical about that, but, you know, I think that's something for each of you. That's again why the monitor is great.
And so there's the monitor is the only way to kind of see how well the air filter is working. You can't like visually look at it and see if it's.
You can't really look at it and see. Here's a little story about that. So we have a home that has a kitchen and a combined living area. It's about 600 square feet altogether, and we have one blue air air filter in there. And when we cook, we have the air monitor is near where we cook. And so you can see, you'll get a spike in indoor air quality from cooking. We go turn the air monitor, the air filter on, which is all the way across this 600 square foot room. It's on the other side of that room. We'll turn it on. And we don't even turn it on high. Usually we just turn it on medium, but maybe we turn it on high. Okay, let's say we turn it on high. 5 minutes, maximum 5 minutes, you will see the air quality go back to green. So my point is, these things are incredibly fast. So if you're in a situation like that, where your air monitor is saying the air quality is bad, and you turn the filter on high, and 10 minutes later, you're not seeing any change, 30 minutes later, it's still bad. Okay, your filter's not. But most of the time, you're going to see a pretty instant change. You know, a few minutes, you're going to see a change in the air quality. And if you're not seeing that, that means you need a new filter. That's the best way to know.
That's great to know. And yeah, Danita, I see your message in the chat about where to get an air monitor. We are going to be doing that whole deep dive into that tomorrow. So a little incentive to come to tomorrow's webinar and hear about.
You know, we can put the air monitor handout in the chat also, just in case somebody can't come tomorrow. But we'll dive into that tomorrow. There's really good ones out there. But yeah, we'll talk more about that tomorrow.
Great. Well, I think we've covered most of the questions. Oh, yeah, maybe one final in the Reed's question. Michael's asking about, have you heard of electrostatic precipitators?
Yeah, don't go there. I mean, well, I don't know. They're like zappers that are supposed to like, you know, like somehow zap the dust particle. That might work for larger particles, but I think that's a kind of technology that is really sort of being phased out. HEPA is just the kind of gold standard now, and it's so easy and cost effective to get HEPA filters now that I think that those other things are just like they're going away, and I wouldn't go there.
Okay. Well, that's great advice. Well, thanks, Brian. That brings us right to the hour mark. Yeah, really appreciate the great deep dive and all your expertise on this. We will send, the recording, the slides, either later today or tomorrow. And don't miss the rest of the Clean Air Week webinars and all the resources available. And we'll be with Brian tomorrow. So thank y'all so much.
Thanks. And thanks everyone for tuning in today.
Thanks, Brian.